Good morning, everybody. My name is Luca, and I wanted to describe you in this tutorial how to use one of the dashboards we developed during the INTUIT project. In particular, this dashboard is a tool aiming at assessing the performance effect of policies affecting three key performance areas: cost efficiency in terms of charges, the capacity in terms of number of regulations, and the efficiency in terms of route extensions. The data we use come from a route choice predictor that calculates aggregated efficiency metrics for a given route, as a function of the unit rates set in the different charging zones, which in turn determines the charges paid to fly a route. The dashboard enables the evaluation of the trade-off between flight efficiency, cost efficiency, and capacity by means of different interactive visualizations, and assess the effect of unit rates and route choices on ATM performance. Okay, so the first thing to do is to log in into the platform this way. Okay, just a few seconds to load the whole environment. Okay, here it is, the main entrance of the visualization platform. We are going to select the dashboard we wanted to describe and wait a little bit for the data loading. Okay, almost done. Okay, here it is. This is our the main page of the multi-objective optimization engine, the dashboard. Here it is. As you can see, we can find three different parts. On the leftmost part, we have a lateral bar used to set the environment, the visualization environment. And then we have two windows, the optimization window here, and the analysis window there. We are going to describe a little bit more in details the three parts. So, to show the functionalities of our dashboard, I'm going to play a little bit the role of the analyst during a possible decision-making session. For this end, I'm going to set up the environment, the visualization environment. I'm choosing here the routes we want to analyze. For instance, in this case, the Canary Island London routes is okay. And here I wanted to select the criteria weights to associate with my preferences. There's a slider for each of the KPIs involved into the decision-making strategy. In this case, route extension, navigation costs, and delay. And this slider can have one of the four positions: none, low, medium, and high, representing the relative importance of these criteria throughout the optimization task. In this case, for instance, for me, it's more important to have navigation costs here, so that, as you can see here, the selection has been reflected into the whole environment, and in particular, it has updated the selected solution widget. The selected solution is represented in orange throughout the whole platform, and while in green we are representing the baseline solution. That is the one we wanted to improve. Okay, so I have selected a triple of criteria, and then I'm ready to analyze the solution, the whole set of solution in the optimization window. For this end, I have at my disposal four different smaller environments, two charts here, the parallel coordinates plot, the scatter plot here. I have also two sets of sliders to filter out some of the unwanted solutions. The filters works on both the criteria part and the indicator composing the different dimensions of the solutions we are analyzing. And here in this corner we have also a table representing the quantitative information of each of the solutions involved into the analysis. The solutions, okay, we have here the labels representing the criteria assigned to each of them, and then here the different indicators. The columns can be ordered as we want. I can select a set of those solutions. Hovering each of them, you can see that by hovering one of them in the parallel coordinate plot, we can see highlighted lines representing the hovered solution. To analyze the solutions, I have a couple of options, as I said before. For instance, I can see it in the parallel coordinate plots. Here we can we are representing the row numbers, so we can also have a normalized representations. By default, all the indicators are represented here. We can for instance, delete some of them, and the graphic is updating accordingly. We can also filter some of the axes by drawing a small rectangle on one of the axes. So we can also move it, and of course this acts like a filter, and we can see different set of options. We can also have multiple filters on each of the axes. By highlighting here the labels of the solution, we can see the corresponding lines. All right. There's also a feature here to put a common scale, and then to different way to order the lines. In particular, we can center on the selected solution or the baseline one. In this way, it's it's simpler for the analyst to compare the different solution that he wants to analyze. If those lines are too much, we can also filter them by those criteria. You can see that the number of solutions is getting filtered by smaller quantity. Another way is to analyze possible trade-offs about pairs of indicators by using a scatter plot. In this way, in this sense, we can here select the indicator we want on each of the axes. There's also a third dimension related to the color. For instance, in this case, we wanted to color the points according to the regulations value they have, and you can see accordingly the different solutions. We have tooltips also useful for have more information about the solution under analysis. And then, as in the case before, we can order the solution in different ways. In particular, according to the min-max algorithm, or relative to the baseline, or relative to the selected solutions, in the same way as we've seen before in the parallel coordinate plots. This way, it's possible to analyze the trade-off about just a couple of indicators. The scatterplot can also have some kind of a Pareto front representation in order to find the optimal set of solutions according to in this case to the charges and the root prolongation indicators. And if we wanted to see more Pareto level sets, we can choose this option here. There. Okay, here it is. There's a new environment. In this case, we are analyzing the effects of a selected solution, like this one, with respect to the baseline, but considering the effects on three different kind of vectors: the airlines, the ANSPS, and the routes. This part is composed by two different parts. One of them is about a geographical map to provide some kind of geographical reference to the problem, and the other one is about providing more quantitative analysis. Concerning the map, the idea here is to represent the indicators of ANSPS, unit rate, controlled A&M, and average charges. A&M are nautical miles, and from one side, and from the other one dealing with the route indicators, that is average charges, number of flights, and the total income. The idea is to represent the NSPS in a choropleth map, like these ones, and the route clusters, like there. We can filter the unwanted items from the map. For instance, in this case, we are just dealing with the main clusters of routes. We can also represent the effects of the selected solution, like this, the baseline, and then compare the two solutions, the selected with respect to the baseline, by clicking on the difference button. Both the indicator for both the ANSPS and routes are colored by different color scales, so in order to allow to ease the comparison between them. In this case, we are analyzing the unit rate. We can change it to the, for instance, the nautical miles controlled, and the graphics are updated accordingly. We can pass to analyze also the quantitative part of the solution by considering the graphics, the three graphics represented here in the rightmost part. In this case, we can also, with respect to the map, we can also see the airlines actors. By choosing one of the actors, the list of the airlines in this case and the indicators are updated accordingly. By default, all the indicators and the airlines are selected, but of course we can perform a selection of a small part of them. All right, and of course the graphics are changing accordingly. The three graphics are providing three different points of view of the solution, of the effects of the optimization solution. In this case, we are analyzing the effect on the airlines, on the selected airlines, on charges, the route prolongation, and regulations indicators. This is like an order scatter plot, like the one we saw before, where each point is colored according to the number represented here, and the size too. The comparison overview provides just the difference, like this one, about the effects of the selected solution with respect to the baseline. A more detailed comparison is allowed here. In this case, we can see the effect. We explicitly see the effects of the selected solution with respect to the baseline. It is possible to choose to represent original values or normalized values, and among them also the absolute values or the change in percentage. All right, and then the last part is a graphic representing the distribution of the different solutions with respect to the whole set. In this case, is about statistical distribution. What we wanted to see is how the solutions are distributed with respect to the whole set, and see if the selected solutions is a good choice for in this case for a given airlines or not. We can also see this part here to show all the solutions. There are solutions repeating everywhere, and that's all.